The first technique for solving linear systems is the graphing method. So let's take a look at that. Get solving linear systems of equations by graphing. So solving linear systems of equations by graphing. Okay, so let's take a look at that. These systems, these linear systems here of equations. Typically, we'll see a system of two equations and two variables here. All right. But before we get into that, though, let's go ahead and look at a word problem I want you to think about here. Let's take a look at this word problem here. Let me say that suppose two numbers. Sorry about that. Two numbers sum to 1, all right, and the difference between them, and the difference between the two numbers, let's say, is 5. All right? So I have two numbers that sum to 1, and the difference between the two numbers is 5. Okay? So let's go ahead and take a look at this word problem. Let's find the two numbers. So find the two numbers. All right? So how do we go about doing something like this here? Well, the first thing we're going to do is let's introduce two numbers here, right? Let's call those numbers x and y, all right? So the first number is x, the second number is y, all right? Two different numbers here, all right? Suppose these two numbers sum to 1. So let's use two variables here, right? So that means what? That means that x plus y is equal to what? 1, right? It says these two numbers add up to 1, all right? And what else? What else do we know? It says what? And the difference between the two numbers is what? 5. That means if I take the difference of these two numbers, x minus y, x minus y, difference, I get the difference of 5, all right? So again, the sum of these two numbers is 1. The difference of these two numbers is what? 5, all right? Now, some of you already know how to solve these types of linear systems. So these two equations lumped together here is called a linear system. In particular, it's a linear system of two equations and two variables. I have two equations here and two variables, x and y. All right. Now, before we get into solving these linear systems, which some of you already know how to do, then now remember, I want you to solve them by graphing in this section here. And the reason why this is called a linear system is because each of these equations I can get in the form of what? mx plus b. I can get both of these equations into mx plus b, which means they are diagonal lines, so therefore they are linear, right? So therefore this is called a linear system. Okay? So now, before we get into the solution here of this system, let me throw a few numbers out here, right? So is this point a solution here? So is the point, let's say is the point, for example, 0, 1 a solution? Okay, in other words, 0 for x, 1 for what? Y. Is that a solution to the system? Okay, so let's check that real quickly, right? If I plug in 0 for x, then for the first equation, I'm going to get what? 0 plus 1, which is 1. Okay, so that's good. Let's check the second equation. All right, so second equation. All right, 0 minus 1. Well, that's negative 1. So that's no good, right? Because I want it to be what? 5. I want the difference to be 5. So therefore, this order pair, while it satisfies the first equation, it does not satisfy the second equation. So which means that this is not a solution, right? So to be a solution, you have to what? Satisfy both equations, right? How about this point here? How about the point 3, negative 2? Is that a solution? Okay, so let's go and check that real quickly. Let's plug in 3 for x and negative 2 for y, because first number is the x coordinate, second number is the y coordinate. Okay, so let's check that for this linear system here. All right, so first equation, 3 plus negative 2, x plus y. Okay, that's equal to 1. Good. All right. Second equation, take the difference between the two numbers. So 3 minus negative 2. So that's 3 plus 2, which is what? 5. So the difference between these two numbers is positive 5 here. So therefore, this ordered pair satisfies what? Both equations. So therefore, it is a solution in this case. So yes. The two numbers we're looking for are what? 3 and negative 2 for this word problem here. Right? For this word problem, the two numbers are what? 3 and negative 2. Okay. Now let's talk about how we can get the solution of this answer. Right? 3 negative 2. How do I get this solution then? By graphing, if you will. Right. Again, this point, this ordered pair is a point. Right. That means what? Since it satisfies both equations, though. Right. That means what? That means it's on both lines. That means this point is on both of these lines. And these are just mx plus b lines, right, which we'll get them in that form in a moment here. Right? So the strategy here is, since this point is on both lines, how do I find the solution given any linear system? Right? Well, the idea then is to graph each line, and since this point is on both lines, then these two lines eventually will intersect each other. Eventually they're going to cross, because this point again is on both lines. So therefore, we just graph each line, the strategy is, and then what? Look for the point of intersection. Look for where the point where these two lines meet each other. All right. So let's verify this answer by graphing each of these lines in the next screen. All right. So let me go and clear this out. So keep this solution in mind here. All right. Let me clear the screen now. So again, I'll put the equations again. So we have x plus y is equal to 1, and x minus y is equal to 5. All right. And remember, the solution we got was 3 negative 2. So let's verify this. All right. Okay. So let's get the first equation in mx plus b form. So step 1 is what? Get each equation. So to solve this by graphing, we get each equation in the mx slope-intercept form, mx plus b form. So here, without me doing the algebra for you, if I simply subtract x from both sides, we see that y is equal to what? Negative x plus 1. Okay? Hopefully you can see that without too much trouble. This one's a little more challenging, but hopefully you see that when you solve for y algebraically without me showing you the algebra at this stage. Hopefully we're comfortable with the algebra. We get y equal to x minus 5. All right? So again, check the mathematics on that, right? Subtract x on both sides, divide by negative 1. Hopefully you get this result, okay? So without me showing you the algebra at this stage in chapter 6, all right? So I have both lines in mx plus b form. Let's go ahead and graph using the slope-intercept method, okay? So again, we should be familiar with that technique of graphing as well, okay? So let's go ahead and make a nice straight line here. Okay? Again, you might want to use a ruler here. So here's the y-axis, all right? Here's the x-axis here. Okay, so x-axis here. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, and 5 here. All right. So let's graph the first line. The first line has what? Has slope equal to negative 1, or negative 1 over 1, that is. And the y-intercept here is going to be what? 0, 1. This is the y-intercept. Okay? Y-intercept. Okay? Okay then. So let's graph the first line. So 0, 1 is my starting point. Again, focus on the first line right here. Don't worry about this here. Focus on the first line only. Correct? So we're starting at 0, 1. The slope is what? Negative 1, 1. That means I'm going to go 1 down, 1 to the right. So I'm going to go 1 down, 1 to the right. Put a point there. Let's continue with this trend. 1 down, 1 to the right. Okay. Now, for graphing solving this system by graphing, you may want to graph a few more points than just 2 points. Of course, 2 points make a line, but for better accuracy, first of all, use graph paper and use a ruler. Second of all, you might want to graph 3 or 4 points. So let me do one more again. So again, but it's easy to get additional points. Just follow the slope. But once I start at the y-intercept 0, 1, I just go 1 down, 1 to the right. I get a point. Keep going. 1 down, 1 to the right. Get another point. 1 down, 1 to the right. Get yet another point. Okay. So again, all 4 points should line up in this situation. All right. So therefore, I'm going to end up with the following then. This is a little challenging here to graph on this sketch pad here, so bear with me on that. Okay, so I apologize for the graphing here, right? But that should be a straight diagonal line. So it's hard to graph me on the sketch pad because I can't really see it on the sketch pad here. I'm just watching the screen as you are as well. So I apologize for that. But hopefully you understand the graphing here. Those 4 points do line up here in this case, okay? All right then, let's graph the second line. Second line here, the slope is what? 1, which is 1 over 1, all right? And the y-intercept here is going to be what? 0, negative 5. Hopefully we can recognize each of these things here without too much trouble. So again, this means 1 up, 1 to the right. Okay. Back up there, it means 1 down, 1 to the right. Okay. All right. Let's start off at 0, negative 5. Again, focus on the second equation now, right? So here's 0, negative 5, 1, 2, 3, 4, 5, go all the way down here. Okay. Then go 1 up, 1 to the right. Okay. So again, 1 up, 1 to the right. Just follow the slope. 1 up, 1 to the right. Okay. 1 up, 1 to the right. Okay. As you can see, this is where the point of intersection is, right? Again, all 4 dots should line up. I'll try to make it a little better this time, but I can't make any promises here. All right, do the best I can. Okay, so there's the point of intersection. So there is my solution right there. Solution. Okay? So this big point I marked as the solution here, right? What is it? Well, 1, 2, 3, 1, 2. So again, as I mentioned, the solution is 3, negative 2 here. Okay, so make sure we see that. Again, all we're doing is what? First of all, we get each equation in mx plus b form. Then we graph them. We see where they cross. And here these two lines cross at what? 3, negative 2. So that's our solution. The point of intersection is the solution. Okay? The point where the two lines cross, where the two lines meet, that's the solution to the linear system here. Okay? Let's try another one here. So let's see if we can solve these systems by graphing. Now there are other algebraic techniques that we'll look at here in a moment, but let's go ahead and look at solving by graphing first. Let me clear up the screen. And let's go ahead and try this system. Let's go and solve by graphing. Okay, so again, solve by graphing. Okay, so on the exam, if I give you a problem and I say solve by graphing, don't solve it using the algebraic technique, which I'll show you in a moment here, but you want to solve it by graphing. I need to see graphs here. Okay, so let's try this one. Let's look at 3x minus y is equal to 3, all right, 2x plus y is equal to 2, all right. Let's go ahead and get each equation in mx plus b form then. So for the first equation, to get it, again, do the algebra on your paper here, but hopefully you see that y will be equal to 3x minus 3, okay. Hopefully you see that after you solve for y. Not too bad. Second one, just subtract 2x here, so y is going to be what? Negative 2x plus 2. Hopefully you see that. All right. Again, check the algebra. I'm not going to show you the algebra on getting y by itself now. We should be familiar with that concept at this stage. All right. So let's go ahead and look at the sketch of these two lines. You're going to do the best you can to draw it out. Okay. So let's see here. So let's get 1, 2, 3, 1, 2, 3, 1, 2, 3. And 1, 2, and 3. Okay, let's start with the first equation again. Let's graph the first equation. So what's the slope here? Well, the slope is what? 3, which is 3 over 1, all right? And the y-intercept is going to be what? Well, that's going to be 0, negative 3. Okay, so 0, negative 3. Make sure we see that here, okay? So let's start off with that point, 0, negative 3, right down here, okay? And then I'm going to go what? 3 up, 1 to the right. Okay, so 3 up, 1 right. Okay, so 1, 2, 3, 1 to the right. Let's do one more. 1, 2, 3, 1 to the right. Again, all 3 points should line up diagonally, as you see here on my screen. But again, I'll try to connect them as straight as I can, though it's harder to do on the sketch pad here once again. Okay, that's not too bad. Okay, so that's the graph of the first line, y equal to 3x minus 3. Let's graph the second line, negative 2x plus 2. What's the slope there? That's negative 2, which is negative 2 over 1, if you will. All right, I'll treat it as that. Put the negative on top if you don't mind. So that means what? That means what? 2 down, all right, and 1 to the right. Slope-wise, all right, rise over run, all right? And the y-intercept here will be what? 0, 2. Hopefully you can see that b is 2. So I'm going to start off at 2 here on the y-axis. It's the y-axis, x-axis, all right? So here's 0, 2, and I'm going to go what? I'm going to go 2 down, 1 to the right. So 2 down, 1 to the right. In fact, there's my solution right there. So I can stop right there in terms of the graphing here. I connect them carefully here. Okay, so again, I apologize for the sloppy graphs on the sketch pad, so bear with me on that. But there's the point of intersection right here. You can see it clearly. This point here is the solution, and the solution here is going to be what? 1, 0, as you can see. 1, 0. Okay, so my solution, once again, let me write out here, it's more clear. It's going to be 1, 0. All right, and you can quickly check that by plugging in 1 for x and 0 for y. These numbers are small enough for you to check real quickly. 3 times 1 is what? 3 minus 0, so that's 3. Check. 2 times 1 is 2 plus 0, 2. Check. So this is indeed the solution here. All right. So again, graph each line. First of all, get them in mx plus b form, and then graph them and see where they cross. Okay. Let's try another one here. Now let's look at this situation. All right. Let's find the solution to x plus y is equal to 1, and x plus y is equal to, let's say, equal to 4 here. All right. Let's look at that situation. So let me draw my grid here. So here's y. Here's x. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay. So let's get up each one in mx plus b form. So y is going to be what? Negative x plus 1. Just subtract x from both sides. As you can see here, not too bad at all. And here, same thing, subtract x from both sides. Y is equal to what? Negative x plus 1. Sorry, plus 4 here, so I meant to say. Sorry about that. Let's subtract x from both sides. All right? But let's observe something here. That these two lines have the same slope. If you recall earlier, earlier from your homework problem, from the homework problems here, when two lines have the same slope, they are what? They are parallel lines. So these lines here, if you will, are parallel lines. So that means what? Well, that means they're not going to cross. That means they're not going to intersect. In fact, let's go and graph it just to verify it, all right? So let's graph the first one. So start off at 0, 1 here on the grid, all right? The slope is negative 1, so I'm going to treat that as what? As negative 1 over 1. So 1 down, 1 to the right. 1 down, 1 to the right. Okay? So 1 down, 1 to the right. 1 down, 1 to the right, and so on. So you can see the line looks like this here for the first line. So again, sorry for the sketch here on the sketch pad. All right. Second line, 0, 4 is the y-intercept. So 1, 2, 3, 4. All right. So again, the slope is the same. 1 down, 1 to the right. So 1 down, 1 to the right. 1 down, 1 to the right. So again, these lines are not going to cross because they have the same slope, because they're parallel. Okay, so again, they should look parallel here. Sorry for the sketch pad graphing here, but these lines should be what? Parallel to each other, all right? Because they have the same slope. So therefore, they're not going to cross. So therefore, this linear system here has what? No solution, because these lines do not cross. No solution. And what do we call a linear system with no solution? We call that a dependent solution. Oops. Sorry, wrong term there. I meant to say we call that an inconsistent solution. We'll talk about the dependent solution in a moment here. All right, sorry about that. Inconsistent system, I meant to say. Inconsistent system. Okay, so this linear system, again, is inconsistent. So a linear system where you have two lines that do not cross, that means they're parallel lines, then we say the system is what? Inconsistent. Okay, sorry for the confusion on the terms here, right? So inconsistent system is what we're looking for on the homework. Okay, so again, so in the back of the book, you'll see the answer inconsistent in this case, if two lines are parallel. All right, let's try another one. Okay, let's go and solve this by graphing here, if you will. Alright, let's solve 4x minus 2y is equal to 4. Sorry about that. And then y equal to what? 2x minus 2. Okay, let's go and solve this system by graphing. And this one is not too bad in the sense that, look, the second equation, y is already in mx plus b. So in other words, the form on the second equation is already ideal for us for graphing. So I don't have to do any algebra on the second equation. But I do have to do some algebra on the first equation to get it in this form, mx plus b. Right? So solve for y here. So we'll do the algebra for you. 4x minus 2y equal to 4. All right? Subtract 4x on both sides of the equation. All right? So we get negative 2y is equal to negative 4x plus 4. Okay, write the x term first. It's negative. 4 is positive. Negative 4x plus 4. Then divide both sides by negative 2. So divide everything by negative 2 here. Okay, so y will equal to what? Negative by negative is positive 2x. 4 over negative 2 minus 2. Alright? Hey, look what happened here. The first equation in mx plus b form, happens to be what? The second equation, right? Happens to be the same thing, right? Same equation right here. So what does that mean? That means that these two lines is essentially the same line because they have the same mx plus b equation. So these two lines is the same line. So when you graph them, actually, you're just graphing one line. You're not graphing the you're not graphing two lines, or you're just graphing one line because both of these lines are the same. All right. So the graph of this is just one line. Okay. So let me go and graph that. All right. Let's go ahead and graph this line again. Both lines have the same mx plus b equation, so therefore it's just one line. All right, so let's go and graph this. So again, what's the slope here? The slope is what? 2, which is 2 over 1. Again, that means 2 up, 1 to the right. Make sure we see that without me writing it. The y-intercept is what? 0, negative 2. Make sure we see that without me writing it out. So I'm going to start off at 0, negative 2. There it is. And go 2 up, 1 to the right. Again, the graph of it is just one line, so therefore I'm not going to graph more than 2 points here. Just going to graph one line here, so this is no big deal. Just this diagonal line here. Okay. So that means what? Since both lines, the graph of them is the same line. Both lines are the same. That means what? That means that if a point is on one line, that means it's automatically on the other line because it's the same line, right? So again, if a point is on one line, that means it's automatically on the other line because both lines is essentially the same line, right? Are essentially the same line. So, and how many points can we have on a line? Well, we can have infinitely many points here. So how many solutions do we have in this case? Well, in this case then, since it's only one line, since both lines, the graph of both lines, in other words, their mx plus b forms are the same, then it's just one line. Then in this situation, we have what? Infinite solutions because there are many points on this line, not just the 2 points I've located here. All right. So therefore, this solution, this linear system, has infinite solutions here, or many solutions. All right. And we call it a linear system with infinite solutions, where it's just one line, where the graph of it is just one line, because both equations have the same mx plus b forms. Right. We call such a linear system a dependent system. Okay. So sorry for messing up on those two terms here. But this is a dependent system. Okay, so again, be familiar with the term inconsistent and dependent. So a system is inconsistent when there are two lines that are parallel, they do not cross. A linear system is dependent when both lines is essentially the same line and the graph of it is just one line. Right? That's a dependent system here in this case. Okay, so distinguish between those two terms here. Those two terms again. Inconsistent and dependent. Alright, so be familiar with that. Alright, let's go and do another one here. Again, get used to solving by graphing here. Okay, let's go and solve this linear system by graphing. Okay, if I say solve by graphing on the exam, then you need to show me the graphs here. Alright? So let's look at this system here. X equal to 2 and 3x plus 2y is equal to 4. All right, let's go ahead and make my grid here. So here's y. All right, here's x. Okay, so let me go ahead and make a few marks here. 2, 3, 1, 2, 3, 4, 2, 3, 1, 2, 3, and 4. Okay, so well, let's graph the first line. Well, the first line, if you remember, x and a number, there's no y at all. What kind of a line is that? That's a vertical line, if you remember, all right, from section 5.2, all right? Again, if you don't see y at all, x is always 2, that means we have a vertical line at 2. So you just go to 2 on the x-axis here, for example, and you make a what? Vertical line. Okay, just do it carefully. Take our time with that. So this is the line x equal to 2. All right? Not too bad. Just recall that fact from chapter 5 here. All right? Here I do need to do some algebra here. So again, without me showing you the algebra, when you solve for y, you're going to get what? You're going to get negative 3 over 2x plus 2. All right? So subtract 3x, divide by 2. Hopefully you get this result. Negative 3 halves x plus 2, all right? So let's go and graph this line then. So the slope is what? Negative 3 over positive 2. That means 3 down, 2 to the right. That's how I'll treat that. And the y-intercept is 0, 2. Okay, so make sure we see that. All right, so 0, 2 here, my starting point. And then go what? 3 down, 2 to the right. So again, this means 3 down. The rise is negative 3, so 3 down. The run, for the horizontal change, which is the run, excuse me, is positive 2, so 2 to the right. Okay, then, so again, 0, 2, my starting point, go 3 down, 1, 2, 3, 2 to the right. In fact, there it is. So there is where they cross, right there at that point. If I can just make a straight line, that would be nice, but I'm having a hard time with this on the sketch pad here, so bear with me. I apologize for that. Okay, so apologize for that here. Okay, so this is the point where they cross right here. Okay, so again, make it real dark so you can see it clearly, all right? And this point is what? 2, negative 1. Okay, so this solution right here, the point where they cross, and sorry for the sloppiness on the graph here with the sketch pad. It's hard to graph lines on the sketch pad here. Okay, so solution is going to be what? 2, negative 1, as I mentioned. Okay, so, oops, sorry about that. 2, negative 1. Okay, that's our solution here. Okay, so always give your solution, if there is one, as an ordered pair. All right, x comma y. Okay, so again, we graph the lines and see where they cross. That's really the idea in this section here. All right, let me give you some problems. Let's take a look at another technique, an algebraic technique called the substitution method. So let's look at one technique called the substitution method. Substitution method of solving these linear systems because it's not always convenient to solve a linear system by graphing. For example, suppose the solution to a linear system is a fraction answer or a decimal answer. Well, it's real hard to estimate what that fraction or decimal is if we're eyeballing it on a graph. So therefore, it's more accurate if we use an algebraic technique to solve these linear systems. Right? But of course, graphing has its own importance, right? Okay? So let's go ahead and take a look at this method called the substitution method. All right? So let's start with a real simple linear system here. All right, let's start with this one. Suppose the first equation is y equal to 3. All right? And the second equation is 3x minus 2y. Let's make it 3x plus let's not do minus 2. Let's do 3x plus 4y is equal to, let's make it equal to something like 5, for example. All right. So well, since y is equal to 3, so again, what kind of a line is that? That is a horizontal line where there's no x at all. It's just y and a number. If you remember, that's a horizontal line. But again, we're not going to graph these lines. We're just using an algebraic technique called the substitution method in this section. All right. So the way it works is you substitute the y. In this case, y is 3, right? So I simply have to plug 3 in for y into the second equation, and I'll be left with just x. So let's do that. So I'm going to get 3x, so second equation becomes 3x plus 4 times what? Times y, which is 3, all right, equal to 5, all right, not too bad. So 3x plus 12, 4 times 3, is equal to 5. All right, now I just get an equation with just one variable, x. I can finish solving it. Subtracting 12 on both sides of the equation. So 3x is equal to negative 7. So therefore, dividing both sides by 3, I get x is to be what? Negative 7 over 3. So negative 7 thirds. So my solution as an ordered pair, if you will, is going to be negative 7 thirds x comma y. What's y? Y is equal to 3. That's given to us, right, to begin with. So there's my solution. All right. Now, if you're trying to solve this by graphing, though, it's going to be hard for you to estimate negative 7 thirds. Negative 7 thirds is what? That's negative 2 and what? Negative 2 and 1/3. All right. And there's no way for me to estimate 1/3 here just by eyeballing it, even if I have graphing paper. Okay. So again, the substitution method is a more accurate method for solving linear systems. Okay, the idea is what? You plug in for one variable into the other equation, then you finish solving the equation. All right, but let's look at another one. Let me clear out the screen here. Okay, let's try this problem. All right, let's look at for example y equal to 4x plus 1, and okay, y equals 4x plus 1. And 2x minus 5y is equal to 13. All right. Let's see how this linear system turns out. So I'll solve this by what? By the substitution method here. All right. Now, as you can see, like the previous example, except the previous example I had y equal to 3, right? Now I have y equal to something else. Y is equal to what? 4x plus 1. So since y is already solved for here in terms of x, since y is already solved for, and this is even mx plus b, right? So I simply have to substitute 4x plus 1 in for what? In for y in the second equation. Since y is 4x plus 1 in the first equation, I'm just going to plug this expression in for y in the second equation. Can we see that? So this is how the substitution method works. Okay. So you use the first equation and then substitute that into the second equation. All right. So let's go to finish the second equation. So second equation becomes what? 2x minus 5 times y, but what's y? Y is 4x plus 1. So parentheses 4x plus 1. I need to plug it in using parentheses because there's two terms for y in this case. All right. And that's equal to what? 13. So after notice that after I make that substitution, though, what happens? Well, what happens is that I just get an equation involving x, and I can finish solving this equation for x. So again, not too bad, just like the previous example, right? Let's go and finish solving this and do it carefully. So 2x brought down, distribute the 5, negative 5 that is, negative 5 times 4x, negative what? 20x, negative 5 times positive 1, negative 5, equal to 13. All right, combine like terms here. So 2x minus 20x is negative 18x minus 5 is equal to 13. Adding 5 to both sides of the equation here, I get negative 18x is equal to what? Positive 18. So dividing both sides by negative 18 here, okay, hopefully we got x equal to what? Negative 1. All right. So x is equal to negative 1 in this linear system. So the x-coordinate of the solution is negative 1. Well, what's the y-coordinate? Once you get the y-coordinate, that's not too hard because look, y is equal to what? 4x plus 1 from the first equation. So just plug it back in. In other words, so we have, so let me continue here. So x is negative 1, right? And we know that y is equal to what? 4x plus 1 from above right here, all right? So just plug in negative 1 for x. So therefore, y is going to be what? 4 times negative 1 plus 1, which is what? Negative 4 plus 1. All right, which is negative what? Negative 3. All right, so therefore the solution is x equal to negative 1 and y equal to negative 3. And as an ordered pair, then that'll be what? Negative 1 comma negative 3. So our solution is negative 1, negative 3 using the substitution method. All right, let's try another one. All right, let's look at this equation here. Let's try this one, if you will. Let's look at 2x. Let's look at negative. Sorry about that. Negative 2x plus y is equal to 3. All right, and let's look at 4x minus 3y is equal to 1. 4x minus 3y is equal to 1. All right, so my linear system is what? Negative 2x plus y is equal to 3, and 4x minus 3y is equal to 1. All right, how do I go about solving this now? Well, this one's a little different from the other two examples, right? The other two examples I have y already solved for, so here I don't have that now, right? But we can get it to be that way. It's not too hard at all. For example, so pick any equation you want to pick. Right, first one or second one to start with, doesn't matter. You start with any one equation. You take your pick. All right, but it's easier, as you can see, to solve for y in this case in the first equation. Can we see that algebraically? So you want to start with the first equation here, right? So let me start with that. Let me start with negative 2x plus y is equal to 3. Right? Let me get y by itself. That's just adding 2x to both sides. I hope you can see that without too much trouble here. All right? So y is going to be what? 2x plus 3. Can we see that from the first equation? All right. Now I'm just going to substitute this expression, 2x plus 3, in for what? In for y in the second equation. Again, don't substitute this in for x now, right? Because y is equal to this, not x, right? So you need to plug this in for what? For y, because that's what y is equal to from the first equation, all right? So what does the second equation becomes then? Well, it becomes this. It becomes 4x minus 3 times y, which is 2x plus 3. So parentheses 2x plus 3 equal to 1. All right, let's go and quickly solve it then. So 4x, distribute negative 3 times 2x, negative 6x, and negative 3 times 3, negative 9. That's a negative 6 there. Sorry about that. All right, equal to 1. Combine like terms. 4x minus 6x, negative 2x minus 9 equal to 1. Add 9 to both sides of the equation, as you know. So negative 2x is equal to what? 10. All right. Dividing by negative 2 on both sides. So x will be negative what? Negative 5. All right. So therefore x is negative 5. But what's y? Again, well, I can do it right here. I see that y is what? 2x plus 3. So therefore y is going to be what? 2x plus 3 right here, right? And x is what? Negative 5. So that's going to be 2 times negative 5 plus 3, which is negative 10 plus 3, which is what? Negative 7. So therefore my order pair solution is what? Negative 5 comma negative 7. All right, can we see that? Again, not too bad here. Let's try one that does involve a fraction answer here, all right? Let's try another one. Let me go and clear out the screen here. Okay, let's look at this one here, a little bit more on the challenging side here, all right? 3x minus 5y is equal to 2. 3x minus 5y equal to 2, all right? And what else? 2x minus y is equal to 4. So 2x minus y equal to 4. All right. This one's a little more challenging. The solution involves fractions here. All right. Let's see how that turns out. Okay then. So what do I do again? I start with any one equation. So start with either the first one or the second one, and isolate one of the variables. You can isolate y if you want. You can isolate x if you want. It depends on the problem. But again, in this case, though, it looks like algebraically it's best to start with the second equation. Can we see that? Start with the second equation and solve for what? Which one is it easier to solve for algebraically, for x or for y? Hopefully you see that it's y that's easiest to solve for. So let me start with the second equation here. Okay, so let me start with it. So 2x minus y equal to 4. All right, let me solve for y. Subtract 2x on both sides. Again, make sure we're sharp on solving for y here. That's just getting it in mx plus b form, which is what we've been doing when we graph in chapter 5, right? So negative y equal to negative 2x plus 4, all right? Dividing by negative 1 to everything, both sides that is. Y is going to be what? Positive 2x, or negative positive, minus 4. Okay? So let's substitute the 2x minus 4 in for what? In for y once again, because that's what I solved for in the second equation. But actually, I shouldn't point at this y here. I should point at the y above. Okay, because it makes no sense to substitute back into the equation we started with, right? So again, I started with the second equation this time to solve for y. I did the algebra. There it is. Y is what? 2x minus 4 from the second equation. And I'm going to substitute that into the what? Into the first equation. So I apologize for that, right? So plug it into this y here in the first equation. So the first equation becomes what? First equation becomes 3x minus 5 times the quantity 2x minus 4, all right? That's what y is in the from the second equation, right? Equal to what? 2. All right. Let's go ahead and solve for x then. Again, x is the remaining variable I can finish solving for. So 3x, negative 5 times 2x, negative 10x, negative 5 times negative 4, positive 20. Again, simplify carefully here, right? Review if you have to on these concepts. After I distribute, no more parentheses. Okay? Equal to 2. All right? 3x minus 10x is what? Negative 7x plus 20 equal to 2. Subtract 20 on both sides of the equation. Let's look at negative 7x is equal to negative 18, as you can see. All right, dividing both sides by negative 7 here, I would have a fraction answer here. Hopefully you can see that. X is what? Positive 18 sevenths. Can we see that? 18 over 7 positive. Negatives divide out. Okay? So x is 18 sevenths. Well, what's y? Well, y is what? 2x minus 4. So let's plug that in. This time I'm plugging a fraction. A little more challenging here, if you will, all right? You don't want to use your calculator here to do fraction calculations for you, all right? So therefore, y is going to be what? 2 times x, which is 18 over 7 minus 4. All right? I'll do it by hand here if you don't mind. So that'll be what? That'll be 2. Think of this as 2 over 1 if you like, right? So 2 times 18 is 36 over 7 minus 4. And put a 4 over 1 if you like, all right? But what's the common denominator? It's going to be 7, right? So multiply the 4 by 7 over 7. Okay? Again, you can just punch in the calculator if you're not comfortable doing fractions by hand, as I'm doing here on the whiteboard. So that's going to be 36 over 7 minus what? 28 over 7. All right? And 36 minus 28 is what? 8 over 7. Okay? So therefore, x is 18 sevenths. Y is what? Y is 8 over 7. So the order pair solution is 18 over 7, comma 8 over 7. Okay, so in this case, again, it's impossible for us to get these accurate answers if I try to solve it by graphing. I definitely need the substitution method in this situation here. All right? We'll look at the other method called the addition method in the next section here. All right? But let's do a few more problems here. Let's try this one. Okay, let's go ahead and try this one here. Let's look at this one here. Negative 2x plus 4y is equal to 6. So negative 2x plus 4y is equal to 6. All right, and x is equal to 2y. Let's go and solve this system by substitution. Now this time, the second equation is very nice, and because x is already isolated and is equal to 2y, right? So I just have to substitute this in for x in the first equation. Can we see that? All right. So again, x is equal to 2y in the second equation. Let me start with that. Let me start with that. Let me plug it in for what? For x in the first equation. So don't plug this in for y, right? Because x is solved for, not y here. Okay. X is 2y. So therefore, substitute the 2y in for x in the first equation. Can we see that logic here? All right. Since x is 2y in the second equation, I could plug it in. I could plug that in for x in the first equation. Okay, so the first equation becomes what? Negative 2 times 2y, because that's what x is here in the second equation, all right, plus 4y equal to 6. All right, let's go ahead and simplify that. Negative 2 times 2y is what? Negative 4y plus 4y is equal to 6. All right, 4y's cancel out, so I get 0 is equal to 6. But look, the variable's gone. That's a strange conclusion that we have. Right? We haven't seen this before, right? But look at this equation, though. 0 equal to 6. Is that true? Well, of course not, right? This is always false. So after I use the substitution method, I end up with a false statement. So what's our conclusion here? Well, you may conclude that there are no solutions. All right? And which means what? This linear system is what? Remember the term? Inconsistent. So this is an inconsistent system here, if you will. All right. Now, why is that so? Because these two lines are what? Parallel lines, right? In fact, if you try to get the mx plus b for this, you're going to see it has the same slope for both of these lines here, right? Sure, in fact, let's do that here. What's y equal to here for when x is 2y? Just divide by 2, right? Both sides. That's 1/2 x, all right? What's y equal to in here if I solve for y, for example, right? So I'm going to add 2x to both sides and what? Divide by 4, right? So y is going to be what? Y is going to be 1/2 x, and then 6 divided by 4 plus 3/2. All right. But again, I didn't show you the algebra of getting these equations in mx plus b form, right? But hopefully you can see this here. All right. But you see that the two lines have the same slope, so therefore they're parallel lines, and therefore they will not intersect. So that's why there's no solution, and it's an inconsistent system in this case. So this linear system is what? Inconsistent, we say. All right. Let's try another one. So again, bottom line is what? When you use the substitution method and you get a false statement, you get a nonsense equation like this, 0 equal to 6 at the end, which is false, then you know these two lines are parallel and it's inconsistent. All right, let's try another one. All right, let's look at something like this. 6x minus 3y is equal to 6. So 6x minus 3y equal to 6. And also 2x minus y is equal to 2. So 2x minus y equal to 2. All right. So how do I solve this by substitution? Well, again, start with any one equation. But hopefully, again, you see that the second equation is the best equation to start with, and solving for y is the easiest way in terms of the algebra. All right. So let me do that. Let me start with the second equation, and let me solve for y here, if you will. Okay, so let me start with 2x minus y equal to 2 from the second equation here. All right, let me get y by itself. All right, subtract 2x on both sides. Hopefully you can, again, see the algebra without too much trouble here. Negative y is equal to negative 2x plus 2, dividing by negative 1 to everything. Hopefully we're comfortable getting things in mx plus b form anyways. And that's it. Y is equal to what? 2x minus 2. Can we see that? Negative, negative is positive. And 2 divided by negative 1, negative 2. All right? 2x minus 2. So again, I started with the second equation, and I isolated what? Y. Let's substitute this expression in for y in the first equation. So let's go all the way up here now. Okay, let's go up to y. So substitute this in for what? Y in the first equation, since I started with the second equation. So the first equation becomes what? 6x minus 3 times y, which is 2x minus 2. So 2x minus 2 equal to what? Equal to 6. All right? Let's finish solving for x. So 6x, bring it down, distribute a negative 3. Negative 3 times 2x, negative 6x. Negative 3 times negative 2, positive 6, equal to 6. Simplify, combine like terms. 6x's will cancel out again. Look at that. The variable terms canceled out. All right? And I get 6 equals 6 this time. Is this a nonsense equation? Well, in this case, it's not, because 6 is equal to itself. And this is, in fact, a true statement. Okay, so it's not a false statement, it's a true statement. So unlike the last example, and using the substitution method, I ended up with the what? With a true statement. Always true. So what does that mean? That means that these two equations is basically the same line. And that means we have what? Infinite solutions here. And what term do we use for a system that has infinite solutions? We call it a dependent system. Okay, a dependent system. So basically, both of these lines have the same mx plus b form. If you solve for y in the first, see the second equation I solved for y for you. It was what, 2x minus 2. Let me do the same thing here for the first equation. Watch what happens. 6x minus 3y equal to 6. All right. If I subtract 6x to both sides here, okay, so I get negative 3y is equal to negative 6x plus 6. Divide by negative 3 to everything. Okay, get rid of it. Y is equal to what? Negative 6 over negative 3 is positive 2x. Positive 2x. Sorry about that. X right there. And 6 over negative 3 minus 2. So again, look. I get 2x minus 2, which is exactly what I get here. Sorry for this mark right here. Okay, cross that off. All right, so again, both equations have the same mx plus b. If you remember that again, that means it's the same line. That means there are infinite solutions. That means we have a dependent system here. So again, using the substitution method, if you get a false statement at the end, that means it's inconsistent. In this case, we get a true statement at the end, 6 is equal to 6. Then we have what? A dependent system. Okay? So again, know when we have a dependent, know when we have an inconsistent system based on the substitution method here. All right? Let me give you some prompts to solve using the substitution method and post the answers to in Blackboard. Okay, let me go and clear out the screen. All right, let's go and solve the following linear system and post the solutions in Blackboard, if you will. Let's start with this one here. Let's start with 3x minus minus 4y is equal to 9, and y is equal to 2x minus 1. Okay, so this is a nice system since y is already solved for in the second equation. So it's not too bad. All right, number 2, let's go ahead and try this one here. Let's look at x equal to 4y minus 2. All right, and x equal to 6y plus 8. All right. Again, so here is looks somewhat different, but again, just take either one to start with. Substitute one in for the other. Okay. So again, make sure we know how to work with this. All right. In this case, what I'm saying is what? Substitute, for example, if you choose to start with the first equation, x equal to 4y minus 2, just substitute 4y minus 2 in for what? In for x in the second equation. And then you can finish solving for y. Okay? So this one's actually not that bad. So don't let that confuse you here. Right? Let's do one last one here. Let's look at 2x plus 3y. Oops, sorry about that. 2x plus 3y is equal to 3. All right, and y is equal to negative 2/3 x plus 1. Okay, that's a 3 right there. Sorry about that. Okay, so again, y equal to negative 2/3 x plus 1. All right, and this is 2x plus 3y equal to 3. So solve these three linear systems using what? The substitution method, and post your answers in the discussion area in Blackboard. Okay, so we'll answer any homework questions you have in class. Okay, so until next time.